when a charged particle, say plus Q, is placed in a magnetic field B, it will experience a magnetic force which is given by its charge into velocity, and if it is moving with velocity v, velocity cross producted with the b vector. So yes, it is in the case of single charge. Suppose for a current carrying conductor, suppose there is conductor, say, let's say this is P, Q, the length of conductor, that is length of conductor is equal to PQ is equal to L. See, when in this conductor, when we apply a potential difference, so this side become positive, this is negative, this is positive, this is negative, the negative electron will be drifting with a velocity which we call it as a drift velocity. Not only single electron, there will be number of electrons. So when a conductor PQ of length L, an area of cross section, its area of cross section, this is area of cross section of the conductor, area of cross section of the conductor is equal to A, and it is placed in a magnetic field. So in the along magnetic field is along positive z axis. This is placed, the conductor is placed, magnetic field is along positive z axis, current flowing current I in positive y direction. This current is flowing in this direction. When current is flowing and the magnetic field is applied, it means the conductor is kept in uniform magnetic field. So the current in the conductor flows. How the current is in the conductor flows? The current in the conductor flows. The current in the conductor flows due to drift electrons. What is drift electrons? The electron, when we are applying a potential difference here, this positive charge will attract the electron and the electron will not flow, it will drift. This phenomenon is already explained in current electricity, that what is drifting of electron. So the current in the conductor flows due to drift of electron in the opposite direction, because current is flowing this direction. Electron, this is positive side, electron will be drifting in this direction. So we can call it as V drifting in this direction. So as the conductor is placed in magnetic field, uniform magnetic field, each electrons, because you see here the conductor, this is the current is due to flow of electrons in this direction which is drifting. So force on one electron, Fm. See, force on one electron, force on one electron, that is, we call it as F magnetic force. Therefore F magnetic force is equal to charge into drift velocity into B, because electron is moving with the drift velocity V, and this is one electron. There will be a n number of electrons in a conductor. If it is a conductor, it will have n number of electrons. So drift velocity, where Vd is equal to drift velocity. Vd is equal to drift velocity. So as the conductor is placed in the magnetic field, each drifting electrons will experience a magnetic Lorentz force because the charge is moving in the magnetic field, and hence current carrying conductor will also experience a magnetic force because each electrons will experience a magnetic force, and hence the entire conductor will experience a magnetic force. So since Vd is equal to drift velocity of the electron and charge of electron what is charge of electron is equal to minus of q, that is minus of q is equal to minus of E, or we can say the force where F is equal to force, that is magnetic force on each electron. Magnetic force on each is equal to Q into V into B, the charge is equal to minus E into velocity is drifting velocity into magnetic field. This is the force Fm, or we can write is equal to minus E into Vd, where V stands for drift velocity cross producted with the magnitude. So this is a drift velocity, but so what is the net force acting? Because this is Fm force acting on one electron. There are several n number of electrons in the conductor. So we have to find out what is the total force. What is the total force on n number of electrons in the conductor? So now we can say Lorentz force due to one single electron. So total force acting on the conductor. Total force on the conductor due to magnetic field B on all electrons present in the conductor is equal to F, or F, how we can say number of electrons in the conductor, number of electrons in the conductor multiplied by force on one electron, because there will be, suppose 100 electrons are there and one electron will have a force of Fm, then total force on the conductor is equal to 100 electrons into force on one electrons. This is the, so force on one electrons, this we have to. So we can say that F is equal to n into Fm vector. This is total number of electrons, or F, where n is equal to total number of electrons as it is we have written, and total number of electrons, and n is equal to n into volume, that is n is equal to electron, that is charge density, electron density R, number of electrons per unit volume. So F is equal to n, so F is equal to, where n is equal to n into volume, where n into volume is equal to area into length, where volume is equal to length of the volume of the conductor is equal to its area into its length. This is the length of the conductor. So we can write F is equal to NAL into Fm. So okay, F is m into n into Al, or F, total force on the conductor is equal to N into A into L into Fm. What is Fm? Fm is equal to, should be minus E, yeah, into minus E into Vd cross B. This is the Fm. Fm is given by this expression. So total number of electron multiplied by one single electron. That is the total force on the current carrying conductor. Now we will define one more term, that is I into L. Why it is vector? Because if there is a current is flowing like this is of length L and current is flowing like this, from here to here it is direction. So IL is equal to current in your elementary length, current in a length, and its direction is along the direction of current. It means IL. What is IL? IL is the current element vector. IL is the current element vector, that is current in a given length. Current in a given length, that is called current element vector. Its direction is along the current direction. Therefore, L vector. Therefore, we can say L vector and drift velocity vector. Because length is this way, current is flowing this way. So L vector is in this direction, drift velocity is in this direction. The electron is flowing here, is negative charge, minus Q. Negative charge, minus Q. Okay. So we can say the force, net force is equal to, total force, we can find out net force is equal to net force on the charge is equal to N. So we will take NEA VD. We will take NEA, and we take L inside, minus L into Vd cross B vectors. From this expression. Okay, so this is NEA. See, as it is, current in a conductor is given by I is equal to NEA into drift velocity. This we have seen, this we have derived the expression in where? We have derived this expression in current electricity chapter. So NEA and VD, now we have to take the VD out. How we will take the VD out? See now here, from this, see here, now we have to see here, this drift velocity in the conductor is in this direction, and this direction we can say negative of drift velocity. What we are interested, this can be written F is equal to NEA into minus L Vd vector cross B vector. We can write like this, minus L Vd vector, because you take it inside, it can be taken, it can be multiplied with B also, L can be multiplied with B as well as D also. So this is equal to NA L into Vd. So Vd vector, and this is the direction, length vector. Why length vector? Because length vector I into L vector. IL is equal to, what is IL? IL is equal to current in a length or elementary length. If it is dl, it is elementary length. It is a vector along the direction. So L is in this direction. L is, now we want, if since L is in the direction, so minus L into D, how we will write? Minus this portion, minus L into Vd. This can be written as L into, because L is a scalar, Vd is a drift velocity is a vector, minus Vd vector we can write is equal to L into minus a negative Vd. This is negative Vd is in this direction. It means we can say this is equal to L into minus Vd. So this is L Vd vector is in this direction. Understood now? LVD is in this direction. Now what is VD? This is the direction. Now we can write L, therefore minus LVD is equal to, this way we can write it, minus L into VD, or which can be, we can write VD. VD, we will take it as a scalar into L vector. How? See, minus VD is in this direction multiplied by a scalar. Minus VD is in this direction. If you multiply it by a scalar L, the direction will be same, because a vector multiplied by a scalar, it does not change the direction. So we can say this is also equal to L into minus VD vector in this direction. Now what is L is in this direction, L. This L is in this direction, and this L is multiplied with a magnitude Vd. It means this will be magnitude with L vector. So it means what? L minus Vd is also, L minus Vd is in this direction. This is L minus Vd vector, and Vd into L vector also in this direction. So how we can say? We can say minus, here it is given minus L into Vd vector can be written as Vd. Vd is a scalar into L vector. This we can, this is very important relation we have derived. So this we will be substituting here. Very simple. Minus LVD means what? This is a scalar, this is vector, negative of VD. See, VD is in this direction, negative in this. It means the entire length will be in this direction. Okay. And which is a L is in this direction multiplied by a scalar, it is also in this direction. This and these are equal. Very simple. You have to understand this fact. Now, what is Fm? So, total force. Total force is equal to NEE, and we will write minus LVD in place of VD, in place of this portion. In place of this portion, we will write this portion. VD into L vector into B vector. So is equal to NEE drift velocity into, because by taking the magnitude, that scalar out, L cross B. So this is the expression for force on the conductor, which when it is placed in a magnetic field is equal to F is equal to NEAVD. What is NEAVD? It is the current. NEAVD is equal to I, this portion is I, into length of the conductor cross producted with the magnetic vector of this conductor. So this is, as this is for current carrying conductor, and normal magnetic force on a charge is, there are two types of force. First is, this is the magnetic force exerted on the charge. This is the magnetic force exerted on the conductor of length L when placed in a magnetic field. So in scalar form we can write, in the scalar form we write Fm So F vector is equal to I into length of the conductor into breadth. So is equal to I into its magnitude is equal to B into L into sin theta, or is equal to bill. We can remember BIL, bill, sin theta. It means the force is also angle dependent, but theta is equal to angle between these two, L vector and B vector. This is you should not get confused. There are so many BIL. Where I stands for current. Current is a scalar quantity. In fact, it is a tensor quantity. Now let us find out the direction of force given by the magnetic field on this conductor. So this can be found out using Fleming's left hand rule or right hand palm rule. What is Fleming's left hand rule? First we will use Fleming's left hand rule. Left hand rule, it indicates that this is FBV. This indicates B. B is in this direction. This figure along the direction of velocity, and the extended thumb is in the direction of magnetic force. That means if it is Fleming's left hand rule, so for positive charge, the force is inside. Magnetic force is inside. Now here the charge is negative 1 because electron is drifting like this. So here the actual thing is negative charge. Negative charge in that sense, if it is negative charge in that sense, it will be in the opposite sense. If it is inside, it will be outward. That is the direction of magnetic forces along positive x-axis of the conductor. This way, outward. This is positive of this conductor. Let us use right hand palm rule. This is the right hand palm rule. So in the direction of velocity we are keeping, and we are moving towards the B. First velocity, move the finger towards the direction of B. This is the finger. It is for positive charge. Always this rule is for the positive charge, and for the negative charge it is in the opposite direction. Same way, see, when you go like this, move like this, it is inward. It means same thing is inward, means same thing follows, and for negative charge it is outward. It means this way. Outward, this is outward. That is, this is the way. Positive, this is inside is negative x-axis, outward is negative positive axis. So what is the magnitude? The magnitude of force is equal to BIL sin theta. This is the conductor, and current flowing in the conductor is this direction. See, B, I, and I is not a current. Now this is the direction of magnetic field, and this is the direction of L. In that condition, theta is equal to 0 degree. Theta angle between magnetic field and the length of the conductor. Suppose if this is the length vector in this direction, and this is the magnetic field direction. Magnetic field direction. In this case, theta is equal to 180 degree. Here sine of theta, sine of 0 degree is equal to 0. Sine of 180 degree is equal to 0. It means the force is equal to B into I into L into sine of 180 when B vector and L vector are anti-parallel, which is equal to 0. First case, F is equal to 0 when B and L are parallel. That is theta is equal to 0 degree. Here antiparallel means theta is equal to 180 degree. If theta is equal to 90 degree, first case, second case, third case, theta is equal to this is the direction of magnetic field. This is the length direction and this is the length direction. So 90 degree. So F is equal to will sine the angle between B and L, sine 90. Since sine 90 is equal to 1 is equal to BIL into 1 is equal to B into I into L. It means F is equal to F maximum. It means when the conductor is this way, this the conductor length and the magnetic field is in this direction, this conductor will experience maximum force due to this magnetic field. But if they are either parallel, if both are either parallel, if they are either parallel or anti-parallel, the force on the conductor due to this magnetic field will be 0.